If you're interested in the ketogenic diet, keep on watching because this is where it all got started.
Ketogenic diet has neurological benefits. Why do we have to eat such an enormous amount of food?
Complex science, clear explanations. Class is starting now.
Hi, I'm Dr. Chris Masterjohn of chrismasterjohnphd.com, and you're watching Masterclass with Master John. We are now in our 38th in a series of lessons on the system of energy metabolism, and we are now talking for the first time all about ketogenic diets. We talked in our ketone unit so far about ketogenesis in general, and we've seen that ketogenesis is an adaptation to fasting. It allows us to fast, meaning to completely abstain from food for a much longer period of time than we would otherwise be able to, because it rewires our metabolism in a way that allows the brain to run on ketones derived from fat instead of running entirely on glucose, which in a fasting state is derived mainly from our muscle protein. By rewiring our metabolism in that way, we can fast for a very long period of time without completely destroying our lean muscle mass. The ketogenic diet was derived as a way to mimic fasting metabolism in a way that's much more sustainable over time. The ketogenic diet was first proposed in 1921 by Russel M. shown on the right. Wilder was the head of care for all diabetic patients at the Mayo Clinic beginning in 1919. From 1929 to 1931, he was a professor and department head at the Department of Medicine at the University of Chicago. And then in 1931, he returned to the Mayo Clinic, where he was the head of the Department of Medicine of the Mayo Foundation. He served briefly as the head of the National Institute of Arthritis and Metabolic Diseases from 1950 to 1953, and then he retired because he became ill, and you can see 6 years later, in 1959, he died. Historical evidence suggests that fasting has been used to treat epilepsy at least as far back as the era of Hippocrates. But in the turning of the 20th century, there were many modern physicians who were using fasting to treat epilepsy and documenting it more clearly. And one of the things that was discovered in the modern era was that fasting led to a decrease in seizures in epileptics and also led to an increased urinary excretion of ketone bodies, which was a much newer discovery that required modern chemical analysis. Wilder looked at this and said, if fasting can decrease seizures in epileptics and it increases urinary ketones, then maybe the reason, the mechanism by which fasting is treating epilepsy is by leading to increased production of ketones. Maybe it's the ketones that have the anti-epileptic effect. His hypothesis was that acetoacetate, one of the two major ketone bodies, acts on the brain as an anesthetic. And he proposed the treatment would be a high-fat, moderate protein, low-carbohydrate ketogenic diet. Now, the ketogenic diet was actually born indirectly out of the research on the anti-ketogenic diet. Many people at this time were trying to figure out how to treat diabetes. And one of the most common ideas was that you should restrict carbohydrate as much as you can to reduce the stress on the pancreas of secreting too much insulin, but you want to maintain carbohydrate high enough that it suppresses ketogenesis, because diabetes was seen as, in its worst case scenario, leading to ketoacidosis and coma and possibly death. So researchers were trying to figure out how to suppress ketogenesis with diet. And at the time, the belief was carbohydrate is the most suppressive and protein is less suppressive. And fat, of course, is going to generate the most ketones out of everything. So Wilder took this research on how to suppress ketogenesis in diabetes and turned it on its head to say that in epilepsy, we want to maximize ketogenesis. And the way that we do that is we bring the fat as high as we can, maintaining protein high enough to mitigate any loss of lean mass, but no higher than needed, and to restrict carbohydrates pretty much as far as possible. At the Mayo Clinic, Wilder's idea was put to the test. Over the course of the decade following Wilder's proposal, the Mayo Clinic tested the effect of the ketogenic diet in epilepsy and produced several reports. M.G. Peterman produced the initial reports, and then Henry Helmholtz took over and released reports at 5 years, 8 years, and 10 years experience with the ketogenic diet. Peterman described the protocol in detail in his 1925 report. The ketogenic diet would be preceded by 3 days of gradual carbohydrate restriction to ease into the diet. Then the children would be subject to 2 to 3 weeks under close supervision on a very strict diet. It had 10 to 15 grams of carbs per day, 1 gram of protein per kilogram body weight, which is a little under a half a gram per pound body weight because a kilogram is 2.2 pounds. And the remainder of the diet is fat. Peterman acknowledged that you cannot get all your vitamins and minerals on a diet like this. Yes, certain fats are good sources of fat-soluble vitamins, but most of the vitamins are water-soluble, and most minerals are not found in the fatty portions of foods. You will develop vitamin and mineral deficiencies on a diet like this if you don't use supplements. So they added supplements to make sure that the children were getting everything that they needed, at least to the degree that this was understood in 1925. We didn't actually know that much about nutrition then. And then finally, if they needed to, they would restrict the non-fat calories even further, with the goal being twofold. Number one, make sure that ketones are spilling into the urine, which is called ketonuria. And number two, make sure that the seizures go away. After they achieved these goals under close supervision, the children would be released to their homes, and the guidance would be purely by mail correspondence over distance. You can imagine that under these conditions, compliance is a lot harder. In any case, the goal was 3 to 4 months of seizure-free ketosis maintained on the original diet. After they would stabilize in this state, they would then start adjusting the non-fat calories upward. They would do this very slowly. Each month, they would add either 5 grams of carbohydrate or 5 grams of protein. They would alternate so that 1 month they increased carbs, the next protein, the next carbs, etc. That's 5 grams per day, and taking a whole month to let that change sit in. They would cut back on the carbohydrate or protein and stop increasing it if either the seizures returned or if the ketonuria stopped. In general, those two things tended to happen together. The seizures would return if the ketonuria stopped, reinforcing the idea that the ketones were an important part of the treatment. Now, what they're trying to do here is to start with an extreme diet to make sure you get the positive effect you're looking for, and then increase the non-fat calories to find what is the least restriction that we can attain, the most carb, the most protein. What is the tolerable maximum that we can put in without ruining the effects of the diet on ketonuria and freedom from seizures? The initial results that Peterman reported in 1925 were stunning. Keep in mind, first of all, that Peterman's goal here was to treat all of the patients with idiopathic epilepsy. At the time, this dichotomy is still in use, it's just more nuanced now, but at the time, they divided epilepsy into two categories. Symptomatic epilepsy was epilepsy where a particular local part of the brain was damaged. You could see clearly where that damage was, what type it was, and you could clearly attribute the seizures to that local damage. Idiopathic epilepsy was a more generalized defect where part of the brain's energy metabolism or some unknown aspect of brain metabolism was damaged all around in a way where you couldn't pinpoint it, and it was this general defect that was causing the seizures. So all of the children with idiopathic epilepsy were being treated with the ketogenic diet, regardless of whether the drugs at that time were useful. In the modern day, the ketogenic diet is said to be used for refractory epilepsy, which means that the epilepsy does not respond to drugs first. Peterman was using the diet not for refractory epilepsy, he was using it as the first treatment for any idiopathic epilepsy. Now, granted, the drug of use at the time was phenobarbital, which is a barbiturate and has sedative effects. So it was obviously undesirable to use phenobarbital if you didn't have to. And nowadays it's thought that other medications can be used safely with less side effects, and they're easier to use, and that's why they go for them first. In any case, Peterman reported that in these children, using the ketogenic diet as a first line of defense, 60% were seizure-free and 35% improved. That's 95% getting some improvement from the diet, only 5% not improving at all. And out of these 37 patients treated from 3 to 30 months, only 2 of them had to be treated with phenobarbital. 35 of them maintained their benefit with no drugs. Peterman looked for side effects. He reported nausea and vomiting as common early on in the diet, and he relieved them with orange juice. Orange juice is obviously not ketogenic, but his goal was to ease them into being able to tolerate the diet over the long term. He reported no changes to their physical development, their basal metabolic rate, their bone development, or their blood chemistries. In other words, only the nausea and vomiting were the side effects. He was enthusiastic about the effect of the diet on their general behavior. He wrote that in all the children treated with the ketogenic diet, there was a marked change in character, concomitant with the ketosis, a decrease in irritability, and an increased interest and alertness. The children slept better and were more easily disciplined. This action of the diet warrants further study. Almost 100 years later, and there's been very little, if any, study into these other effects of the diet. Just 2 years later, Henry Helmholtz took over the reporting, and his results were nowhere near as stunningly positive as Peterman's. Listen to what he wrote in 1927. The results of the first 2.5 years treatment in the Mayo Clinic were reported in 1925 by Peterman. The time interval in many cases was of necessity too short for a determination of the ultimate outcome, and a review at the present time shows that the results, as published, are not quite so successful as they were pictured. Of the 37 cases in Peterman's series, convulsions have not recurred in 10. The proportions benefiting, according to Helmholtz's report, are shown on the right. Now, this data is taken from 160 patients after excluding 189 of them. 51 of those 189 were excluded because they had symptomatic epilepsy. So clearly the vast majority of their epilepsy cases were idiopathic. Now, Peterman was excluding the symptomatic epilepsy cases. And so in that way, Helmholtz and Peterman are reporting in the same exact way. But Helmholtz was throwing out patients for additional reasons that Peterman was not. So 22 of the 189 were tossed out because too short of an observation period. 89 were tossed out because of inadequate cooperation with the diet, which is clearly the largest factor leading to being tossed out, and 27 for an assortment of other reasons. So we're taking less than half the initial pool of patients, and then we're saying 21% improved to some degree, 36% were seizure-free, but 43%, compared to Peterman's 5%, received no benefit. Unfortunately, I don't know what happened to Peterman. I couldn't figure it out in the time that I had to prepare this presentation. I don't know if Peterman died. I don't know if Peterman moved on to something else and Helmholtz took over. In any case, it's unfortunate to not have Peterman's perspective on the 5-year experience with the diet. Was Peterman biased in favor of the diet? Was Helmholtz biased against the diet? Or is this difference between Peterman's 1925 report and Helmholtz's 1927 report simply a matter of an additional several years needed for the clarity on the true effect of the diet? One thing we have to keep in mind is that much of this might be driven by poor compliance over time. 89 subjects that Helmholtz was recording were tossed out of the data because of inadequate cooperation with the diet. But what about the ones that were included? Did they comply perfectly? If you read both Peterman and Helmholtz, it's clear that there was a great difficulty getting perfect compliance with the diet. Well, of course there was, because these are children who are being guided, their parents are being guided by mail correspondence. They're nowhere near the doctors, and they're hanging out with a bunch of other children eating candy. And according to them, quite often when someone's seizures would come back, it was because they'd gotten their hand into the candy jar. And so what are you supposed to do if you don't have perfect compliance? So we really don't know if in a clinical setting where you could achieve perfect compliance, would the results look more like what Peterman described in 1925 than what Helmholtz described in 1927? We don't know the answer, but no one who's studied the ketogenic diet has ever reported results anywhere near as optimistic as Peterman's initial results. So the answer is that probably compliance has always been an issue for everyone, but probably in no practical scenario can you get results that are much better than Helmholtz's. Indeed, the numbers that he reported at year 8 and year 10 look very similar to what he reported in the 5th year shown on the screen. Much has happened to the ketogenic diet in the years following the Mayo Clinic's experience, and several other treatment centers, especially Johns Hopkins and Harvard Medical School, have been incredibly important in the development of the ketogenic diet. Some of the major turning points are shown on the screen. After Wilder proposed the diet in 1921 and Peterman reported the results in 1925, just a little more than a decade later, Merritt and Putnam discovered that the drug diphenylhydantoin, also marketed in the modern day as Dilantin, had the anti-seizure effects of phenobarbital without the sedative effects. This was seen as a gold mine of relatively side effect-free medications that could be used to treat epilepsy that were a lot easier than using the ketogenic diet. So over the course of the late 1930s through the 1990s, interest in the ketogenic diet waned and very few people were using it. In fact, Wellis, in the citation at the bottom of the screen, suggests that this basically had a snowball effect because as fewer and fewer people were involved in implementing it, the people who did implement it had fewer dietitians that knew what they were doing to help them. And in fact, even the people implementing it as doctors may have not fully understood all the nuances of how to implement it well. And the cases where it was not implemented well because not enough people had the expertise made it look bad, which discouraged people from using it even further. Nevertheless, one of the important milestones was in 1971, in this period of waning interest, when Huntenlocher developed the MCT oil-based ketogenic diet. The goal of the MCT oil diet was to use medium-chain fats derived from coconut that are much more easily turned into ketones. You can then get the same degree of ketogenesis with less restriction of carbohydrate. That makes the diet more palatable because the choices of foods are broader, and it makes it easier to get your vitamins and minerals and fiber in because you can eat more vegetables and other carbohydrate-containing foods that provide important nutrition. The waning interest started to reverse when Dateline featured Charlie. Charlie was an epileptic child who was treated at Johns Hopkins with a ketogenic diet after all the possible medications failed. His father was a movie director responsible for a number of famous films that you've probably watched, many of them comedies. But he also directed a film starring Meryl Streep called First Do No Harm in 1997 that was based on Charlie's case and featured the usefulness of the ketogenic diet. This made it wildly popular in the eyes of the public like it had never been before, and that initiated decades of increased research and a resurgence of its use to treat epilepsy. In 2003, Kossoff developed the modified Atkins diet, which is a diet that is less restrictive, especially of protein. It's based on the induction phase of the Atkins diet, and it achieves similar results in a less restrictive, more palatable way. In 2005, Pfeiffer and Thiel reported the use of a low-carbohydrate, low-glycemic index diet to treat epilepsy, and innovations have continued, but these are the major ones. It was this proliferation of interest in the ketogenic diet post mid to late 90s that allowed the ketogenic diet to start being researched for other things. For example, its use in weight loss, diabetes, and other things that we'll discuss in later lessons. All of that was spawned by the popularity around the treatment of epilepsy that mushroomed in the late 90s and 2000s. What's shown on the screen is a basic comparison of the different approaches that have been used to achieve the same thing, a ketogenic diet that treats epilepsy. The classic ketogenic diet shown on the left is very similar to what Peterman was first reporting. 1 gram of protein per kilogram body weight, a 4-to-1 ratio of fat to non-fat energy by weight, which provides about 90% of calories as fat. You adjust these ratios according to the need and the tolerance, just like Peterman reported doing. And so sometimes it's a 3-to-1 diet, sometimes it's a higher ratio, but 4-to-1 has been the basic classical starting point. The MCT oil diet does not actually restrict carbs or protein in the way that the classic ketogenic diet does. Its goal is to get 60% of calories as MCTs. MCTs are 8 and 10 carbon fatty acids. They constitute about 15% of the natural fat of coconut, and in MCT oil, they're extracted to be 100% of the oil. These fatty acids are not subject to the anti-ketogenic effect of carbs and insulin. Part of the reason is because they travel directly to the liver, where insulin cannot first promote their storage in adipose tissue, and then also they get into the mitochondrion without requiring the carnitine shuttle, so they're not suppressed by the malonyl-CoA that rises in response to calories and carbohydrate via all the signals of high energy status, including but not limited to insulin that we've discussed in previous lessons. What that means is that MCTs are independently ketogenic and you don't need to restrict carbs and protein. But if you're going to push the MCTs up to 60% of the calories, you obviously are restricting carbs and protein because you have to incorporate such an enormous amount of MCTs into the diet. So when it's practically implemented, although it's not achieving ketogenesis through restricting carbohydrate and protein, 70% of the total calories are coming from fat, 10% of them are coming from protein, and 20% of them are coming from carbohydrate. So it's still a low-carb, low-protein diet. The modified Atkins diet is modeled after the induction phase of the Atkins diet. It allows 10 grams per day of carb of any type except you can exclude fiber, but it does restrict sugar alcohols. It allows them to gradually increase to 20 to 30 grams of carb per day. They get about 65% of calories as fat, and there's no restriction of protein, except, as with the MCT oil diet, if you're deliberately trying to push your fat calories up to 65%, you do wind up eating less protein than you would if you weren't trying to push your fat calories up that far. The low glycemic index is really the oddball in the group because this diet is only modestly ketogenic. It only leads to a blood ketone level of about 1 millimole per liter, at least the beta hydroxybutyrate level of 1 millimole per liter, so maybe a total ketone level of somewhere around 1.5. This is very modestly ketogenic, and yet it seems to work. It allows 40 to 60 grams per day of carbohydrates, but only if the carbohydrates have a low glycemic index. 20 to 30% of calories is protein and about 60% of calories is fat. Now, let's look at what the evidence says on the ability of these various diets to treat epilepsy. There are data on the screen from 2 studies that compared, on the top, the classical ketogenic diet to the MCT oil diet, and on the bottom, the classical ketogenic diet to the modified Atkins diet. And so let's look at these one at a time. In the top table, the classic diet is shown on the left, and the MCT diet is shown on the right. In each case, you have the number of children followed by the percentage of children in parentheses, and we'll focus on the percentages. If you want to look at the degree of treatment between the 2 diets, you compare the percentage on the left to the one on the right. But if you want to see whether it was statistically significant difference, meaning does the statistical analysis support that whatever difference is observed is probably due to a real effect instead of an effective chance, then what we want to see on the right is a p-value of less than 0.05. We can just look at the p-values alone to see that all of these p-values are very, very high. None of them are anywhere near 0.05, which suggests that the 2 diets are essentially equivalent in their ability to treat these children, or if they are different, you would need a much larger, much better statistically powered study to see the difference. Nevertheless, if you look at some of these numbers, you can see 6.8 versus 2.7 for greater than 90% seizure reduction at 3 months. That makes it look like the classical diet is better, and maybe we just don't have enough statistical power. That difference persists, 8.2 but to 5.6 at 6 months. As you go on to 12 months, though, 9.6 versus 9.7 have greater than 90% seizure reduction, 17.8 versus 22.2 greater than 50% seizure reduction. It looks like over the course of 12 months, this diet is, these 2 diets are substantially equivalent. Now, let's blow up this second table to see the tinier numbers on the screen. This is looking at the classical ketogenic diet and the modified Atkins diet. And the easiest thing to do is to ignore the categories on the right that separate this into children of different ages and just look at the total pool of children. If you just look at the p-values, what you'll see is that they're all a lot higher than 0.05, suggesting the modified Atkins diet is equivalent to the classical ketogenic diet. Now, if you look at the comparisons on the right, you'll see one of these p-values has an asterisk. That's singled out for being less than 0.05, and that means that there was a statistically significant difference between the classical ketogenic diet and the modified Atkins diet for being seizure-free 3 months after the diet therapy. And if you look at the numbers, it's 9 versus 4 children, 53% versus 20%. That actually does look like it significantly favors the ketogenic diet because we're talking about more than double the number of children achieving freedom from seizures. On the other hand, if you look at this table, you can see 1, 2, 3, 4, 5 comparisons made in this group, 10 made over here, 15 made over here. To say a p-value is less than 0.05 means that there's a less than 5% chance that you would observe this difference if it was attributable simply to random chance. If you make 20 comparisons, you are bound to get one that looks statistically significant, but is still a result of random chance. They made 15 here, and so the chances are fairly high that they could achieve one of these having statistical significance and it still being an effective chance. So it looks here, the general trend in this study seems to favor under some circumstances, maybe in the youngest children at the shortest time point, you see the most rigorous effect showing that seizure freedom is better maintained on the classical ketogenic diet than the modified Atkins diet. If we come back here, we saw a similar trend where when we were looking earlier on, when it was 3 months, 6 months, at the earlier time points, there was a general tendency for the classical diet to be better. So maybe if any of these is superior, it is the classical diet, which is the one that restricts carbohydrate the most. But the evidence that there's anything superior among these diets is at best equivocal. If we could summarize the overall results of research in the modern era, we can look no further than this Cochrane review, which is a very prestigious association that conducts systematic reviews of evidence. They reviewed all of the randomized controlled trials that looked at the ketogenic diet for epilepsy. And according to their results, they say they identified 7 randomized trials that recruited 427 children and adolescents with no adults. They could not conduct a meta-analysis, meaning pool all the data together, due to the heterogeneity of the studies, meaning there were too many differences in methodology and characteristics between the studies to pool the results. The reported rates of seizure freedom reached as high as 55% in a 4-to-1 ketogenic diet group after 3 months, and reported rates of seizure reduction reached as high as 85% in a 4-to-1 ketogenic diet after 3 months. These results are actually almost as good as Peterman's, but those are the maximum results. The ones that we just saw on the screen, for example, didn't look as good as these do. They went on to say that the most commonly reported adverse effects were gastrointestinal syndromes. It was common that adverse effects were the reason for participants dropping out of the trials. Other reasons included a lack of efficacy and non-acceptance of the diet, the same challenges faced in the early days by the Mayo Clinic. Although there was some evidence for the greater anti-epileptic efficacy of a 4-to-1 ketogenic diet over lower ratios, the 4-to-1 ketogenic diet was consistently associated with more adverse effects. Again, they say the evidence for any comparisons is rather weak. They go on to say all of the included studies assess the efficacy of dietary interventions in children. However, the evidence for the use of dietary interventions in adults with epilepsy appears to be anecdotal. Therefore, further research is required to provide high-quality evidence for the use of dietary interventions in adults, in addition to expanding on evidence in pediatric populations. Although there are no randomized controlled trials showing the benefits in adults, we have case series supporting the efficacy in adults. A case series means just follow a bunch of people who tried the diet and tell us what happened. This is what Peterman and Helmholtz were doing in the early days. And according to this case series, 29 adults and adolescents with a mean age of 32 years, ranging from 11 to 51 years old, were initiated on the ketogenic diet and followed until it was discontinued. 52% of the patients had a significant reduction in seizure frequency on the ketogenic diet, including 45% with more than 50% reduction. 31% had no improvement, 7% were unable to successfully initiate the diet, and 10% had a greater than 50% increase in seizure frequency. Now, note about this increase, this is a case series. It's not a randomized controlled trial. If they had randomly allocated half of the patients to the ketogenic diet and the other half of the patients to no dietary change or some other diet that's not effective, probably a much larger number of those patients would have had an increase in seizure frequency. So that doesn't mean that the ketogenic diet caused that increase. It might just be that it didn't benefit those patients and they were bound to increase anyway. Moving on, the ketogenic diet can be used safely in the adult and adolescent population with a response rate similar to those seen in children. Case series also support the benefit of the low glycemic index diet for the treatment of epilepsy. This is the diet that is only moderately ketogenic. On the screen is data from one case series, and you can see the description of what they did on the right. They say, we reviewed the charts of patients who were initiated on the low glycemic index diet for intractable epilepsy over the course of 2 years. There were two categories of patients. The first category is those who were placed on the diet while they were waiting for the traditional classical ketogenic diet. There were two reasons for this. One was scheduling constraints, and the other was the parents were not sure that the kids would be able to comply with the full-on ketogenic diet. The second group of patients had demonstrated improved seizure control on the ketogenic diet, but they were unable to tolerate the constraints and they couldn't stay on it, so they were transitioned to the low glycemic index diet. On the left, we see the data, and the data is broken up into these two categories of patients. The white bars are the ones who got only the low glycemic index diet, and they got it while they were waiting to get onto the full keto diet, or because their parents didn't trust they could tolerate the full keto diet. And then in gray bars are the patients who did benefit from the ketogenic diet, but transitioned away from it because they couldn't comply with it over time. And what you can see is that, first of all, the number of patients is small. There's 19 patients represented here. The number of patients is plotted on the vertical axis, and it's separated into how many patients got more than 90% benefit, meaning more than 90% reduction in seizures, how many patients had 50 to 90% reduction, how many had less than 50% reduction, and how many had no change or an increase in seizures. And what you can see is that out of these 19 patients, only 2 of them did not benefit from the diet. And 10 of them, which is almost half of them, had a greater than 90% reduction in seizures. This looks comparable to what you would get with the other more strong, more intense ketogenic diets. Now, it's really important to realize that this isn't randomized. And so the reason that that's important is that there could be a subset of children for whom the low glycemic index diet would work well, and other subsets for whom it would not. And the only way to really make that comparison is to take the same pool of patients and randomize them to the full ketogenic diet or the low glycemic index diet. Nevertheless, it's clear that for many patients with intractable epilepsy, just using the low glycemic index diet, which is only moderately ketogenic, does benefit epilepsy. So there you have it. The origins of the ketogenic diet is as a treatment for epilepsy to mimic the conditions of fasting. As it's gained in popularity, we are now starting to look at the benefits of ketogenic diet for other conditions. And we'll look at those possible benefits in future lessons. But for now, we'll say two things. Number one, it's clear that the ketogenic diet is very effective for at least a large subset of patients with epilepsy. This is probably true for adults as well as children. And there are a variety of different versions of the ketogenic diet that are all beneficial for at least a subset of these children. So for any kind of epilepsy, at least the ketogenic diet should be considered because there is no other diet that has that kind of effect on epilepsy. And in fact, at least a subset of children can be treated with this without drugs. Now, on the other hand, there are some side effects of the ketogenic diet, and we will talk about those as we progress on to talking about some of the downsides and some of the ways that ketogenic diets need to be troubleshooted. But the second thing that we can say is that nothing in this presentation clarifies the mechanism. And although we don't know why the ketogenic diet is effective, there are hypotheses that we can explore. And exploring those hypotheses about the mechanism in the next lesson will allow us to generalize from this. If we better understand how the ketogenic diet benefits epilepsy, we can then better understand how it might be useful in other conditions, obviously neurological ones, but other conditions where that same set of mechanisms might be applicable. And understanding the mechanism will be the bridge between understanding just the efficacy in epilepsy and the potential to benefit many other things. So with that, we'll end the lesson here and talk about the mechanism next time. The audio of this lesson was generously enhanced and post-processed by Bob Devodian of Torian Mixing, giving you strong sound and dependable quality. You can find more of his work at torianonlinemixing.com. To continue watching these lessons, you can find them on my YouTube channel at youtube.com/chrismasterjohn, or on my Facebook page at facebook.com/chrismasterjohn, or you can sign up for MWM Pro to get early access to content, enhanced keyword searching, self-pacing tools, downloadable transcripts, a rich array of hyperlinked further reading suggestions, and a community with a forum for each lesson. So if you really want to own these lessons, study them, and get the most out of them, sign up for MWM Pro at chrismasterjohnphd.com/pro. All right, I hope you found this useful. Signing off, this is Chris Masterjohn of chrismasterjohnphd.com. You've been watching Masterclass with Master John, and I will see you in the next lesson.